You've heard the word programming, right? It sounds kind of complicated, maybe even a little intimidating. But here's the thing, it's literally everywhere. It's in your coffee maker, your car, and for sure in the apps you scroll through every single day. So today, we're going to pull back that curtain and show you the simple, powerful ideas behind the code that runs our entire world. Let's dive in. So let me ask you something. Think about your phone, or the laptop you might be on right now. We call them smart devices, don't we? I mean, they can calculate things in a split second, connect us to anyone on the planet. They can even help create art. But are they actually smart? Well, here's the twist. Not really. Nope. For all their incredible power, a computer is basically the world's best follower. It is only as smart as the instructions we give it. You take those instructions away, and what do you have? Just a box. A silent box of metal and plastic. Okay, so if computers need instructions, what are they? What do they even look like? Well, that's where we get to the absolute heart of programming. We call these sets of instructions a program. And honestly, the easiest way to wrap your head around it, just think of it like a recipe. Seriously, a recipe for a machine. And that's really all it is. At its core, a program is just a super detailed list of instructions. It's a step-by-step guide that tells the computer exactly what to do to get one specific job done. And that job could be anything from something as simple as adding 2 plus 2 to something as mind-blowingly complex as launching a rocket into space. Check this out. This is that recipe idea side by side. Over here, you've got a recipe for a cake. You need exact ingredients, you follow the steps in order. And over here, a super simple program. It just says, take one number, add a second number, and then show the answer. See? It's the same logic. A clear, step-by-step guide to get exactly what you want at the end. And this quote just nails it. Programs are what breathe life into the machine. They're the brain, the logic. They're the reason a computer does anything at all. Without a program, all that fancy hardware is just, well, it's just a very expensive paperweight. All right, so we've established that programs are instructions, but how do we as humans actually write them? How do we talk to a computer in a language it gets? Well, we need a bridge between the way we think and the way a machine thinks. That bridge, that's what we call a programming language. You can think of it just like any human language, like English or Japanese. It has its own words, its own grammar, its own rules. The only difference is, it's not for talking to other people. It's designed for one thing and one thing only, letting us humans tell a computer exactly what we want it to do. No confusion. And man, is that communication gap huge. Just look. We communicate with words, with concepts. A computer, way down in its core, only gets this: ones and zeros. That's it. It's called binary. Can you imagine trying to write your favorite app using only ones and zeros? It would be an absolute nightmare. That's why these languages are so important. They're the translators that do the hard work for us. And it's not like there's just one language for everything. Think of it like a toolbox. You wouldn't use a hammer to tighten a screw, right? Same idea here. There are tons of languages, each built for a specific job. You've got Python, which is the king of AI and data science right now. Java is the workhorse behind most Android apps. JavaScript is what makes websites interactive and fun. And SQL, that's how you talk to massive databases. Okay, so we've got our tools, the languages. But how does a programmer actually go from having an idea, a problem, to, a finished program? It's not just about hammering away at a keyboard. There's a process, a kind of workflow that turns a fuzzy idea into something that actually works. And pretty much every programmer follows these same basic steps. First, and this is so important, you have to really, really understand the problem. You can't solve something you don't get. Next, you plan it out. You make a blueprint for your solution. It's only then, on step 3, that you finally write the code. Step 4 is the fun part. You run it and see what happens. And spoiler alert, that almost always leads to step 5, debugging. This is where you put on your detective hat and hunt for bugs or errors. It can be frustrating for sure, but finding that one little mistake and fixing it, man, that is one of the best feelings. So what's the result of all this? Where does this 5-step process lead? Well, it's not hidden away on some server somewhere. It's literally all around you. These are the invisible instructions that are running your world every single day. Just think about the last time you went to an ATM. When you put your card in, a program checks your PIN. When you ask for cash, another part of the program checks your balance and tells the machine how much money to spit out. Every single step is a set of instructions running inside that box. Or how about online shopping? You go to a website, a program is what's displaying all those products for you to see. You click Buy Now, another program is securely handling your credit card info. And then another one logs your order so it can be shipped. It's like this giant invisible dance, and code is the choreographer. And if you want a really cool example, just think about Google Maps. It's not just a digital picture of a map, right? No way. In the background, it's running these incredibly powerful programs that are constantly analyzing real-time traffic, looking for accidents, and calculating the absolute fastest way for you to get where you're going right now. It's amazing. So when you see how code is woven into pretty much everything, it makes you wonder, right? Why should you think about learning it? And I'll tell you, the answer is so much bigger than just getting a job. Yeah, of course, the jobs are out there. Demand is through the roof. But that's not even the best part. The real magic is what learning to code does to your brain. It's like a workout for your logic and problem-solving skills. You stop just being a consumer of technology and you get the power to become a creator. You could literally build that app idea you've had, or that website, or that game you've always wanted to play. But okay, where do you even start? It can feel totally overwhelming. I get it. We found some great advice from a professor that really cuts through the noise. They said, look, don't try to learn it all at once. Just pick one language that seems cool to you, practice it even just a little bit, but do it regularly. And this is the most important part. Build something, even a tiny, simple project, because the small thing you actually finish is way more valuable than some huge idea you never get off the ground. That's how you actually learn. So that brings us to the end. And really, it all comes down to this. At its heart, programming is just about solving problems. So the question isn't really, should you learn to code? The real question is, what problem out there, big or small, are you going to solve first?